Well, hello, Litcrit. Nice to see you again. Are you having a great summer?
I say, the feeling is certainly mutual.
Oh, that is so nice. Hey, congratulations to you and your country. An outstanding Summer Olympics. You have so much to be proud of.
The British always have so much to be proud of. I do, however, appreciate the platitude.
Never a problem, never a problem. Always a good compliment for you. Listen, I thought I saw you competing in the synchronized swimming. Wasn't that you, Litcrit?
Dr. Niezgoda, water sports are not at all my forte, as I do have a mild phobia to water, but I did win the under the hurdles 100-meter dash.
The under hurdles competition. Hey, Litcrit, hey, where are you going? Litcrit, we've got an article to do. Get back here. All right, well, let's just do the article. The article we have selected for this episode of the Literature Library is entitled The Effects of Low-Frequency Ultrasound on Methicillin-Resistant Staphylococcus aureus. It's an in vitro study. This study was published in Ostomy Wound Management in May of 2010. It was performed by Dr. Teresa Conacher and her colleagues. This is an excellent study that we thought we would offer in support of some of the clinical material that we've been discussing with you today. This study utilized the Arabella device in an in vitro model. You can see here the handpiece being inserted into the test tube. Inside that test tube were inoculums of different concentrations of bacterial organisms. Specifically, the researchers were looking at MRSA based on its resistance. The ultrasonic energy was then turned on, and they looked at bacterial viability as well as other characteristics at different time sequences through the study. They found some very interesting findings. Some of the colony characteristics that they looked at on these MRSA organisms were beta hemolysis. If you see, the control group had beta hemolysis as a maintained property, whereas after 60 seconds of treatment with low-frequency ultrasound, the MRSA organisms lost the ability to accomplish beta hemolysis. They looked at colony size, hyperpigmentation, and odor. And in the control group, these findings were consistent with what you would typically see in normal, healthy MRSA organisms. However, once exposed to low-frequency ultrasound, these characteristics were markedly changed, suggesting there was an impact, potentially a negative impact on the organisms. Teresa Conacher also looked at oxacillin resistance, and as you will note, MRSA organisms in the control group were resistant to oxacillin. However, after treatment with low-frequency ultrasound, the MRSA now became susceptible to the antibiotic. The researchers also looked at MRSA viability, and they used fluorescent staining and immunofluorescent to detect viability. What you will see in this graph is that there was 92% viability of the MRSA organisms when there was no treatment with ultrasonic energy. However, after, again, a 60-second exposure to low-frequency ultrasound, the percent viability diminished by more than half. Pretty significant impact on these organisms with exposure, following exposure to low-frequency ultrasound. This graph summarizes their findings very, very nicely. You can see the control group and the number of colony-forming organisms, very viable, healthy bacteria. However, after treatment times as short as 30 seconds, but clearly after 3 minutes of exposure to the ultrasound, near complete or if not complete eradication of the organisms were identified. Again, impressive findings. This is a scanning photoelectron microscope that you can see healthy organisms, very intact cocci identified in the plates, and following ultrasonic exposure, as you see in plate A, you'll see that the organisms were destroyed. The bacterial cell walls essentially crushed due to the energy impact from the low-frequency ultrasound is disrupting cell walls and killing bacteria. The researchers concluded in this paper that 35 kilohertz low-frequency ultrasound reduces bacteria counts in vitro. Interestingly, this correlates well to what we see clinically. We treat with ultrasound, and these wounds become cleaner and more viable with less positive cultures and less infection. We suggest to you that what was found in the study bears out clinically, that the ultrasound damages the bacterial cell walls, renders them non-viable, non-functional, and therefore non-infective. Dr. Teresa Connor-Kerr also found that there was alterations in some of the other characteristics of the MRSA organisms, suggesting an impact on the bacterial genome, rendering it less virulent and more susceptible to antibiotics. Important considerations when we're performing chronic wound management. And the researchers suggest that there's potential application in utilizing low-frequency ultrasound for infected or colonized wounds, especially those wounds that are colonized with resistant organisms. Hope you found this paper interesting. I wish I had my Litcrit friend here to review this with me, but, well, there you are. My goodness. Welcome back, Litcrit. You missed the entire article.
Dr. Niezgoda, I heard and saw your entire lecture. These virtual wound care glasses are simply incredible. My comments are simply that this article provides supportive in vitro data that strongly correlates with clinical observation. The study design is excellent. The conclusions are scientifically valid.
Well, Litcrit, once again, you couldn't have said it any better. I think these conclusions are very valid and very clinically appropriate. So thanks, Litcrit. I appreciate your participation, even though you ran the under hurdle 100 meter once again. And I guess I'll look forward to seeing you again next month. We'll look forward to seeing you again next month, too.